3. The first question says, in this testing facility, you have to recalibrate the machine after 300, but as you know, they would rather want it. In practice, what happens is they want to do this as quickly as possible, but because doing so takes time, they do it at the longest possible. They will wait for the longest possible time that will meet the demand. So that's what this question is really about. So it really takes 12 seconds to do the test, but to recalibrate every time it takes 30 minutes. Well, if they recalibrate every 300 samples, what would be their capacity? Express the answer in terms of samples per hour. Well, this is a pretty easy question. The capacity in the presence of setup time is really what your batch size divided by setup time plus batch size times the processing time. Well, the batch size at max can be 300. You have to recalibrate after 300. So in that case, what would be the capacity? Because the higher the batch size, the bigger the capacity. As we know, 300 is the max it can be. The corresponding capacity is going to be the max possible. So the batch size of we're doing this in minutes because this is minutes. The batch size of 300. The processing time is 12 seconds, but given this is in minutes, we want this in terms of minutes too. So this becomes in terms of minute. This is 1/5. Alright, let me rewrite this. 330 plus 300 times 1/5. May use a different color here. So 5. So this comes out to be 60. Alright, 300 divided by 30 plus 60 equals to 300 divided by 90 is 3.33 units per minute. But the answer wants it in samples per hour, so multiply this by 60, you'll get 200 samples per hour. That's all to this. So this question, instead of just having this one step, we have another step, suppose. So this step has a capacity of 2.5 samples per minute. With the current batch size of 300, we have a capacity of 3.33 samples per minute. Right? Obviously, we're doing too fast, right? Because this is the bottleneck. Given this is the bottleneck, we have to reduce its capacity. By how much? Well, we want to make the capacity 2.5 samples or units per minute. How do we do that? Well, we set up a new batch size, but we'll find that. So we'll find the new batch size for this, and our setup is still 30 minutes plus our batch size is what we're going to find. Our processing time is 12 divided by 60 in terms of minute. Well, if we solve this, this comes out to be 2.5 equals to, solve for B, 30 plus B divided by 5, because 12, this comes out to be 1/5, or where do we find this now? Exam 3. Sorry. Whatever happened here. Alright, let's do this again. Alright. To the cross multiplication, 2.5 multiplies by 30 is 75, plus 2.5 times b over 5 is 1 over 2b equals to b, or 75 equals to b minus 1 over 2b, or 75 equals to half b equals to 150. So you have to run a sample, or you have to run a batch size of 150. So in the next question, this company is producing two kinds of protein. The demand for the first one is 30 kilograms per hour. The demand for the next one is 2 kilograms per hour. the company can produce of either type 3 minutes per kg. So switching from one to another takes 30 minutes of time. So what should be the batch size? Alright, question asked how much soy, so let's find both. Alright, first the soy capacity, the demand is 10 kilograms per hour. The next one is 2 kilograms per hour, right? So we can produce a lot of soy, switch from soy to whey, produce a lot of whey, and switch from whey to this. So this cycle we have to figure out the length of this. Okay, the setup for each is 30 minutes. So we have two setups, so it comes out to be 60 minutes or 1 hour. Alright, we are ready to solve it now. Well, we need the processing time. The processing time is, the question says, it takes 3 minutes per kg. Okay, processing time is 3 minutes per kg. Right? Now, if it takes 3 minutes per kg, remember we are working in terms of hour here. This is the demand is altogether 12. The setup is 1 hour. The thing is 3 times 1 over 60 comes out to be 0.120 0.05 hour. Right? Processing time is 0.05 hour per kg. Okay, now we're ready to solve this. The formula is again the same. Capacity equals to batch size divided by the setup plus batch size times the processing time. Okay, we want the capacity to be same as demand, that is 12. We want to find out the batch size. The setup is 1 hour plus the batch size is we want to find out. Processing time is 0.05. Okay, or cross multiplication is going to give you 12 plus 12 times 0.05 is 12 times 0.05 is 0.6. 0.6b equals to b, or 12 equals to 0.4b, or b equals to 12 divided by 0.4. 12 divided by 0.4 gives you 30. So our batch size, like this whole thing, has to be 30 kilograms. If we know that, our soy is our bigger one, so the ratio of soy is 12 divided by 12, 10 divided by 12 times 30 comes out to be 25 kilograms. The next question is almost exactly the same. The only difference now is, instead of 2 products, there are 3 products. Now it has to produce soy, switch from soy to whey, produce whey, switch from whey to hydro, produce a lot of hydro, switch from hydro to soy. Well, everything is exactly the same. Now just your demand is 15, add that 3. So we have to find the batch size. Your setup time is now 3, so it's 3 products, so it's become 1.5 hours plus batch size times 0.05. If you go ahead and solve this, you will get B equals to 90. If B equals to 90, now the amount of soy-based protein is 10 divided by 15 times 90 comes out to be 60. Well, that's all there is to this. Alright.